This program, while curated to help you improve your health, contains general advice and should not replace the individual advice of your medical practitioner.
Some people think that this could potentially be a place where certain important microbes might live.
The effect on our digestion.
No way to justify gastric bypass surgery.
Protein is like a pearl necklace.
Peristalsis increases to make room for the new food. Your pancreas starts squirting juices.
And this is one of those instances where a drug like a proton pump inhibitor would seem pretty safe.
We've got this huge tube that runs through us, and that's really how we're, more so than anything, connecting with the outside world.
The main form of life on Earth is microbial. We are a microbial planet first and foremost, and we're privileged to be one of the ultimate distributors of microbes around the globe, because we're very mobile and we can spread them around and we can protect them and us, and in doing so, I think we'll better protect Earth.
In life, it's normal to have ups and downs. But what do we do when we get stuck? I've always been fascinated by the health journey. Why do some people get better while others fail to make the shift? In Season 1 of The Shift, we explore the fascinating field of gut health and help you discover what is really going on with your digestion, microbiome, and health.
The gut is amazing.
Changes our concept of the human body. Become useless to the healthcare system.
We're always shifting. Your genes are shifting, your microbes are shifting, everything is shifting.
I'm Katherine Maslen, and this is The Shift. In episode 2, we explored what you need to do to make a shift. There is no point in consuming all of this information if you're not going to be able to put it into action. My intention is to help you actually make a change, and I'll be offering more on this as we go through the series. In this episode, we're going to begin a journey of discovery about your digestive system and the miraculous things that it does for you every day. It is one thing to be eating an amazing diet, but if you're not absorbing the nutrients from your food, then a lot of that goodness is simply going to go down the toilet. I have seen so many patients over the years that have what you would call the perfect diet, but are severely nutrient deficient due to the dysfunction in their digestive tract. Dr. Felice Gersh is an integrative obstetrician and gynecologist with over 30 years' experience. She started her career as a traditional obstetrician and gynecologist, however decided to move into integrative medicine in 2012. You'll hear the term integrative doctor quite a bit throughout the series. An integrative doctor is a conventional medical doctor that's gone on to do further studies in complementary medicine and have a strong focus on nutrition, lifestyle, and treating the patient more holistically. Felice and I had a fascinating conversation about why the gut is just so amazing.
The gut is amazing. It has so many functions that I didn't know anything about until relatively recently. But of all the different functions, one of the most primary, which is that it's for digesting food and getting nutrients in. If we don't have the right nutrients in our body, we can't work the cellular machinery. We can't burn fat. We can't create energy. And that's a big problem now. We have a lot of people who are very good at storing fat and creating fat, but they can't burn fat. And to actually burn fat properly, if you look at like the Krebs cycle, the TCA cycle, how we make energy, the variety of nutrients with the different vitamins and minerals that we need to actually create energy is very significant. And when you're missing any one of those ingredients, like whether it's manganese or magnesium or one of the B vitamins, which are all critical, you just can't create energy. So we have so many people that are tired. People are dragging. They can't make energy. So if you don't have the nutrition, whether it's because you don't eat it or you can't digest and absorb it because you don't make digestive enzymes, you have overgrowth of bacteria in the small intestine, you don't have proper peristalsis, like nothing is right in the GI tract, so you actually have malnutrition. You have no hope of having your body function properly. And then, of course, the GI tract is so critical for making. Those bacteria are actually factories. They make neurotransmitters, they make vitamins, they make amino acids. So they're very, very functional.
What Dr. Felice Gersh said there was really important, and I'm sure you're already beginning to see that our digestive systems are so much more intricate than we could ever have imagined. Your gastrointestinal system is a beautifully synchronized machine that works endlessly to take the food that you eat, digest it, break it down, and ultimately extract the nutrients that keep you living every single day. And as we'll discover as we go further through the series, your gut is important for so much more than digesting food. In this episode, we're going to explore the intricate way that your gut works and begin to explore some potential problems that can impair digestion and reduce your ability to extract nutrients from your food. I couldn't have a conversation about gut health without speaking to a gastroenterologist. A gastroenterologist is a medical doctor that's gone on to do further training to specialise in issues with the digestive system. I was lucky enough to meet Dr. Marvin Singh, who's an integrative gastroenterologist from California. I asked Dr. Marvin how the digestive system actually works.
The digestive system starts in the mouth, so I tell people you don't always just think about it as your stomach or your colon. From the minute you start salivating when you see the food, to chewing it with your teeth, to swallowing it, and food being processed and broken down in your stomach, and nutrients being absorbed in your small bowel, and then eliminating through the colon, a wide variety of factors are occurring. And the thing to really remember is that it's not just a long tube that has functions on its own as a muscle. This tube is the home to one of the most powerful systems on our body, and that's the gut microbiome. The gut microbiome is composed of trillions of bacteria. Some say 100 trillion bacteria. They outnumber our human cells 10 to 1 and outnumber our human DNA 100 to 1. So I tell everyone that we all look like different people, and we are different people, but we're really just an amalgamation of different kinds of bacteria, viruses, and fungi.
Marvin makes a really good point here, and this is that you need your entire digestive system to work in order to digest food properly. This includes the first stage of digestion that begins in the mouth, and it's the one that people forget about the most. So the question I have for you is, how well do you chew your food? Because if you want to digest well, you need to make it a paste before you swallow it. Now, most of us eat on the run, and we're swallowing large chunks of food. For your next meal, I want you to try this for me. Try chewing your food 20 to 30 times. It actually takes a while and it's harder than you might think, but this is actually what's required if you really want to get this first stage of digestion happening. Your mouth has receptors that will tell your stomach, pancreas, and liver if it needs to prepare for protein, fat, or carbohydrates down the line. Your saliva contains enzymes that will begin to break down your food, and most of all, the food particles that enter your stomach will be so small that your stomach acid will easily break them down in preparation for the next stage of digestion. The way that our bodies break down food is just fascinating. Even small disruptions in this process can have consequences down the line, more than you might realise. Summer Bock is a herbalist and digestive health specialist with a focus on using food as medicine. I asked her what her thoughts were on digestive function.
Your digestive tract is the most intimate interaction that you have with the environment. When you eat food, it is only one cell away from your actual bloodstream. As soon as it's in your body, it's this intimate relationship, and then you digest it and you absorb that, and then that becomes your tissues and your blood and your cells. And I find that extremely fascinating and brilliant that our bodies can break this matter down and make it into us, right? And so I think that's what most people don't realize when it comes to digestion, is that if that process is impaired in any way, if that process is impaired from not having the right microbiome, meaning that the bacteria now aren't breaking down the food fully, then you're missing out on a percentage of micronutrients and macronutrients every single day. So every day, let's say it's even like 4%, maybe it's not that much, maybe 4% lost every day because you're not functioning at your fullest, then that at the end of a year, that's a massive amount. At the end of 10 years, that's a massive amount. And that's when you're gonna start to see those scales tip and start to see more illnesses come on and nutrient deficiencies. It's not gonna take 10 days to do it. It's gonna take years, right? So then learning how to get digestion strong so you don't have a deficiency happening just from the digestive level, that to me is one of the major reasons that I think is overlooked as to why digestion is important.
Reviews help us know that we're hitting the mark with what you need and help us to shape future seasons. I'd really appreciate it if you could take a few moments to leave us a review. I would love to know what you think.
The Shift!
Now, once your food leaves your mouth, it heads down your esophagus and into the stomach, which is the next stage of digestion. The walls of your stomach make hydrochloric acid, which helps to break down proteins and is the most important factor in absorbing minerals like zinc and iron from your food. In a healthy stomach, your food will mix with this acid and begin to break it down before it even enters the small intestine. So it can be a little bit confusing to think about how this protein is broken down, but I asked Dr. Tom O'Brien, who had a brilliant explanation.
Mrs. Patient, protein is like a pearl necklace. Hydrochloric acid made in your stomach undoes the clasp of the pearl necklace. Now you're holding a string of pearls. And the digestive enzymes made by your gallbladder, your pancreas, your microbiota, they act like scissors to cut the pearl necklace into smaller clumps. Clip, 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 until you get down to each pearl of the pearl necklace. That's called an amino acid. Those amino acids can go right through the cheesecloth that covers the inside lining of the donut, right through into the bloodstream, and then your body says, oh, here's some bricks and stone and mortar to make new bone cells, to make new brain cells, to make new heart cells. Amino acids are the building blocks of new cells. Remember, you have an entire new body every 7 years. Some cells regenerate very quickly. The inside lining of your gut's every 3 to 5 days. So snip, 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 snip. The problem is when, for example, nobody has the scissors to break down wheat into each pearl of the pearl necklace. No human can do that. So then you get these clumps of the pearl necklace. They're called peptides. They cause inflammation. The inflammation tears the lining of the gut, your cheesecloth, and now you get these larger molecules getting into the bloodstream.
Now we're going to come back to the microbiome and the concept of dysbiosis. For now, I want to look at what happens when you don't have enough stomach acid. Dr. Leo Galland is an internal medicine doctor and the author of 7 books, including The Allergy Solution. I asked Dr. Leo about the role of stomach acid in protein digestion and allergy formation.
Stomach acid is the first step in digesting protein. So the first thing to understand is that most of the antigens that stimulate allergic reactions, most of them are proteins. There are some carbohydrate antigens as well. Now, the first step in digesting protein is stomach acid. Protein has this very complex 3-dimensional structure that's necessary for the protein to do its job. The stomach acid just causes it to clump, and it loses that structure, and so it becomes much less allergenic. And so one of the factors contributing to the increase in food allergies is probably the widespread use of acid-suppressing drugs. There's some fascinating research that has been done in Austria and also at Emory University in Atlanta, Georgia. People who take drugs that suppress stomach acid, if they have allergies to begin with, over a period of months of taking these drugs, the levels of their allergic antibodies go way up. And if they don't have allergies to begin with, they might start to develop allergies, or at least to show allergic antibodies in their blood.
And this is one of those instances where a drug like a proton pump inhibitor would seem pretty safe, pretty inert, and doctors dish it out left, right, and centre, but the consequences down the line from that are actually quite severe.
And sometimes not even so far down the line. You know, proton pump inhibitors, if you're on them and you're in a hospital, they quadruple the risk that you'll have an adverse drug reaction. And they triple the risk that you'll develop pneumonia. And the death rate from hospital pneumonia is pretty high. So proton pump inhibitor use in hospitals probably kills as many people as car accidents.
Okay, so let's back up a little bit. What actually is a proton pump inhibitor, and what is Dr. Leo Galland talking about here? Well, your stomach acid is produced by these proton pumps, and a proton pump inhibitor works by inhibiting their function, which then stops the production of stomach acid.
They're one of the most commonly prescribed drugs for symptoms like reflux and gastric pain. But creating stomach acid is a vital bodily function, so it makes sense that if you cut this off, there's going to be implications down the line. Proton pump inhibitors were designed to be used as a short-term intervention to help heal stomach ulcers. However, they're increasingly being used for longer periods of time, sometimes with the patient staying on them indefinitely. Since the launch of proton pump inhibitors to the market in 1980, they have quickly become one of the most widely prescribed medicines. In Australia, for instance, prescriptions rose by over 1,000% between 1996 and 2006. They cost the UK economy $100 million a year, and in 2018, the proton pump inhibitor omeprazole was the 6th most prescribed drug in the US. Studies consistently find that proton pump inhibitors are overprescribed. In a study of over 120,000 people taking proton pump inhibitors in Denmark, it was found that just 1/3 met the criteria for long-term use. Once a patient is on acid-suppressing medications, they can develop reflex hyperacidity when they stop taking the drug, which can then turn into a vicious cycle where they find it very difficult to stop due to the symptoms they get on discontinuation. This is one of the most common things we work on with our members at Shift, and in my experience, the longer someone takes a proton pump inhibitor, the harder it can be for them to come off of them. Now, all medications come with potential side effects, but the proton pump inhibitors have an increasing pile of scientific papers showing that they may be doing a lot more than just stopping your reflux. This includes increased fracture risk, acute interstitial nephritis, chronic kidney disease, and it doubles the chance that you will die from a heart attack. And perhaps the most relevant to this conversation is that proton pump inhibitors significantly increase the risk of Clostridium difficile, or C. diff, and its associated diarrhoea, and possibly increase the risk of Campylobacter and Salmonella-related gastritis too. And to top this all off, they've been shown to damage the microbiome of your gut, which, as we'll learn as we go through the series, has a swath of other health implications. So thanks for listening to my little rant. I feel a lot better now. But I'm not the only one getting on a soapbox about these issues. Cardiologist and author Dr. William Davis also has a lot to say about proton pump inhibitors and the implications that they have on our health.
It's becoming clear now that PPIs like Asifex and Prilosec and Protonix have been around for a long time now, that there's an explosion in gastric cancer, stomach cancer now. There's also an explosion in SIBO, small intestinal bacterial overgrowth. That is, bacteria have ascended up from the colon into the 20-some feet of ileum, jejunum, duodenum, and stomach, and people have a 30-foot long infection now to deal with. It shows up as irritable bowel syndrome, fibromyalgia, restless leg syndrome, type 2 diabetes, but it's all about disrupted bowel flora that started with grain consumption and silly medications like PPIs. PPIs are now resulting also in more autoimmune diseases because if you have SIBO, it leads to inflammation, increased intestinal permeability and autoimmune inflammation, B12 deficiency, pneumococcal pneumonia, and a long list of other problems. Point being, this class of drugs, long thought to be benign, is proving to be horrible, including carcinogenic effects.
What do you think of medicine's view of the stomach function and stomach acid of being non-necessary, like things like weight loss surgery where they're just removing the stomach completely these days? How has that happened?
Ignorance, stupidity, and profiteering. In other words, that's what drives medicine. It's making money, even if your health is destroyed by it. So there is no way to justify gastric bypass surgery. It's a completely ridiculous practice. It does result in near-term weight loss, but does not result in long-term health. I've seen many people die from their gastric bypass procedures after several years. So, there's no fat antelopes, there's no fat chipmunks, there's no fat lions. It's only humans who become fat, and their pets who we feed by buying the wrong foods, right? Those are the only creatures on this planet who have problems with weight and type 2 diabetes because we thought we could outwit nature and craft a diet that's better than what we should be eating. And that's ridiculous. There's no need for a silly procedure like gastric bypass. It's ridiculous to think that you can bypass an organ and obtain health or weight loss that way.
It's frightening. A little bit like the appendix. We have a lot of doctors that they'll go in, there's nothing really wrong with it, but they'll whip it out just in case.
I think that science is unfolding, but it's become clear that the appendix is a repository for bowel flora, that it may serve as a source to replenish the bowel flora whenever there's a disruption. So taking the appendix out is not a benign thing, but I don't know how to explain the appendicitis. That is, what is that all about? Is that just a consequence of dysbiosis?
We are so proud with what we've created with season 1 of The Shift, but there is more to come. Make sure you subscribe so you don't miss a thing.
The Shift! The appendix, I think, is a funny little organ there at the end of our colon.
Here's gastroenterologist Dr. Marvin Singh.
I went through training, being taught that it really had no function, and that it didn't really matter whether you had an appendix or not. That's why it's called an appendix, just like a book. This appendix is at the end. You can read it or not if you want. It's there, Some people think that this could potentially be a place where certain important microbes might live, maybe in hiding, kind of as undercover police detectives waiting for the chance to come out if something bad happens. And it's an immune organ and may help modulate immune reactions to certain things. And I don't know if it's fully understood. We know that there are certain, immune implications with having an appendix and whether it's removed and inflammatory bowel disease and things like that. So, I think there definitely probably is a correlation between that and how your immune system functions. And I think perhaps that's some of the reason why some of the thought is shifting a bit to saying that, well, maybe, you don't have to have your appendix removed if you come to the hospital with appendicitis, unless it's perforated or there's an abscess or something bad going on. Maybe we can just kind of treat conservatively with antibiotics to help stop the infection rather than removing it. So I think we may be coming around to that a bit more, perhaps for some of those similar reasons.
All right, let's back up a step and explore what happens when your food leaves the stomach. The next step is that the food's going to enter the duodenum, which is the first part of your small intestine. Now, there's a lot going on in there, so I'm going to try to explain what happens. Now, your pancreas's job is to make enzymes, to break down things like carbohydrates, proteins, and fats. These enzymes that your pancreas makes then get secreted into your duodenum, mixing with your stomach contents to help to start digesting that food. The liver is also an important organ in this process. It produces a compound called bile, which then gets stored in an organ called the gallbladder. Once your body registers that there's fat on the way, the gallbladder contracts, putting that bile into the duodenum and helping you to break down that fat. So what you end up with here is a mixture of macerated food, stomach acid, enzymes, and bile. This mix is then called chyme, and it's about to make its way through the tube that makes up the rest of your digestive tract. Now, you might imagine with so much action here that there's several things that can go wrong at this point. Most of the patients that we see have either a deficiency of hydrochloric acid, pancreatic enzymes, or bile production, or sometimes a combination of these. What this means is that you eat the food and it just sits in your gut and ferments rather than being broken down properly. This is one of the reasons that you might get bloating or indigestion or wind. Some of you that are listening may have already had your gallbladder removed. It's actually quite common. While the gallbladder is quite essential for digestion, it's very common for it to be removed because of infection or other issues going on. I asked gastroenterologist Dr. Marvin Singh what people can do if they have their gallbladder removed.
A lot of times people do okay and don't really have too many problems. Sometimes people get problems with diarrhea because the gallbladder is not there as your reservoir to kind of hold or hang on to the bile as it comes down from the liver, and bile can be an irritant in the GI tract and cause you to have more frequent bowel movements. And so if your gallbladder is infected and you're having pain and you're going to have a problem, then you don't really have a choice. So a lot of times we talk in medicine about, especially in integrative medicine, about preventing disease, and we can do a good job of preventing things from happening. But when something's happened, it's happened, and you just have to kind of deal with it. If I get in a car accident and I break my arm's broken. There's nothing I can do to stop that. I just have to deal with the problem now.
Obviously, when there's a digestive problem, we want to make sure that you're digesting and absorbing your food as best you can. This not only will help you to absorb the nutrients out of your food properly, but it will mean that we are less likely to have undigested food particles sitting in the intestine and causing inflammation, bloating, or pain. From a naturopathic perspective, we want to look at naturally increasing your bile production, stomach acid production, and your pancreatic enzyme production, because it's going to help your natural process of digesting your food. Often we might do this through things like herbal medicine, but also by using dietary interventions that can help to stimulate that digestive process. One of these things are bitters. Now, the name might give it away that things that are bitter have a bitter taste, but when we take them, it has a certain effect on the body. Like me, Summer Bock is a passionate herbalist, and we had a really lively conversation about how bitters actually work in the body.
Well, and the amazing thing about the bitters is that it stimulates the vagus nerve and it tells your body that food is coming in. So peristalsis increases to make room for the new food. Your pancreas starts squirting juices, your liver, your gallbladder, like your stomach, everything. Your saliva increases, the mucus layer on your esophagus increases. Like all of this stuff happens when you eat bitters. And to me, that's just, it's brilliant.
One of the mistakes that people sometimes make is taking digestive enzymes or hydrochloric acid to improve their digestive process, when really it needs to come from within. By eating foods with these bitter compounds, it can help us to upregulate our own natural digestion and avoid the need for these things. Some example of bitter foods that you can include in your diet include bitter greens like dandelion, rocket or arugula, depending on where you're from, watercress and other bitter tasting greens. The other thing is citrus peels, so grating up some lemon rind or orange zest can be a really good addition to things like salads. Okay, let's now talk about the actual absorption process, because it's quite profound what your body needs to do to get that nutrition from your food. Your small intestine is where the bulk of your nutrient absorption occurs. It is 7 metres or 23 feet long and has the surface area of a tennis court. As Summer Bock mentioned earlier, even a small percentage or loss of function can have a significant health consequence down the line. If there's any damage or inflammation in the lining of your small intestine, it can lead to malabsorption of nutrients and health issues down the track. By now you might have heard some things that have made you curious about whether the digestive system is involved in more than digesting food. This is Angela Peiffer, a nutritionist that I met in Seattle, Washington.
We've got this huge tube that runs through us, and that's really how we're more so than anything connecting with the outside world. We're sampling all the stuff that we're putting down us. And so as we start to look at everything that can go wrong and the effect on our digestion, our immune system, the feedback to the brain, the effect on the adrenals even, the effect on thyroid, I mean, everything is, kind of spokes out from there. And so when we start to look at everything that can go wrong without the proper support, that's a really fantastic place to start. What I love most about it is that each case that I work with has a different presentation. So there's a lot of detective work in it. There's a lot of work to figure out, how to connect the dots and what's going to best support them.
We're going to explore some of these connections that Angela mentioned later in the series. Let's move on to the last stage of digestion. This happens in your colon or large intestine, and there's a lot of action happening in here. Metabolically, there's a lot going on because this is where your bacteria in your microbiome are most concentrated. These bacteria have all kinds of actions. Metabolically, they're working really hard to make all kinds of compounds that prevent disease and help your body to function. I thought there was no better person to ask about the microbiome than Professor Rodney Dieterdt from Cornell University. Rodney Dieterdt is the author of The Human Superorganism, an amazing book all about microbiome research. I love the way that Rodney explained the microbiome.
The microbiome is the collection of bacteria, viruses, fungi, archaea that inhabit, in this case, the human body, if it's the human microbiome, but they inhabit all complex organisms. So they're in other animals, they're in plants. There is a soil microbiome, so there are media that are said to have a microbiome. So there is the stratosphere, the upper stratosphere has a microbiome. Water has a microbiome. Soil has a microbiome. So essentially, the main form of life on Earth is microbial. We are a microbial planet first and foremost, and we're privileged to be one of the ultimate distributors of microbes around the globe because we're very mobile and we can spread them around and we can protect them and us, and in doing so, I think we'll better protect Earth.
Now that we know how your gut works, what goes wrong when we get symptoms? In the next episode of The Shift, I'm going to dive into the causes behind bloating, bowel changes, and all of those embarrassing symptoms that we don't like to talk about.
Coming up on The Shift.
whether it's chronic diabetes, whether it's autoimmune diabetes, depression.
I hated myself, basically. When I was bloated, these emotions would come up where I really didn't like myself.
And these things weren't meant to be used long term.
But also, your body's not getting rid of some of the bad things.
The most common condition that gets diagnosed is called IBS, Irritable Bowel Syndrome.
Yeast have now become resistant to all the traditional therapies.
I hope you're loving the information in the shift as much as I do. But maybe you're thinking, what do I need to do for me? Take our online assessment to discover what your gut is up to. Go to theshiftclinic.com/quiz.
The Shift!
This series is produced by Must Amplify. Hosted by Katherine Maslen. Executive producer Ronsley Vaz. Music and sound design by Shade Furlong. Thank you to all of our experts. For more details on them, go to theshiftclinic.com/gut.
Still listening? Can you think of somebody whose life could change by listening to The Shift? Why not send this to them right now? Together, we can help to make a shift.
The Shift!
Thank you for listening.
Every listen or download of this show
and hence this voice
directly funds the ending of sex
and human trafficking.
A voice for a voice.
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 Find out more at
Amplify
Impact.com.